This week we have one lesson. We're going to finish up Module 3 this week. We have one lesson, the practice test and the test, all this week to get that done and out of here so we can move on to Module 4. Module 4, I think, will take up most of between now to Thanksgiving. And so we'll try to get that wrapped up by Thanksgiving and be getting close to the end of the semester here by that point. So, hey, I'm gonna be upfront with you guys. I know that life outside of our virtual classroom affects life inside our virtual classroom sometimes. And I have students that share things with me that's going on that's affecting their school life, and I understand that because that's how life works, right? We can't always separate everything real nicely. So right now I have something potentially going on outside of these virtual walls that may affect inside these virtual walls. So I'm going to be upfront with you guys, let you know. 3.5 years ago, I had leukemia and I had to have a bone marrow transplant. I was out for a year. I was in the hospital like 105 days. It was a big thing before I was able to come back to teaching. Last week, I had a blood test that showed it might be returning. They had little bitty traces of leukemia in a just a checkup, a three-year checkup since a bone marrow transplant. They say it's highly unheard of for a bone marrow transplant to fail after 3 years, but not entirely unheard of. So I've had some blood work redone last week, probably another week before we get those results back to start checking to see what's going on. And I don't really know the path at this point. May just have to go back on a chemo pill, which is bad enough, but hopefully won't have to go back into a whole major bone marrow transplant procedure thing. If I do, that's takes up a lot of life because that happens in Little Rock, and then you have to live within that 30 minutes of the hospital for the next 3 months because you have no immune system after that. When you have a bone marrow transplant, you have zero immune system. So they tell you if you run a fever, you have to be at the hospital like immediately because you have no defense against anything. So I'm hoping I don't get back to that. It's a huge step backwards for me if I have to go back to that. And so we're looking to avoid that and hopefully have some other medication and stuff to get on top of this and keep this from getting to the point last time. Last time, see, it took a month and a half to 2 months to even diagnose what was going on. I was having all these symptoms and problems, and nobody really knew what it was. We couldn't figure out what was going on. The symptoms were weird. They didn't match anything that you'd think leukemia. I had joint pain. My shoulders would be killing me. And I'd be trying to take ibuprofen or put on heat or put on ice packs, and nothing would help. And then the next day I'd wake up, oh, my shoulders feel great. But now my knee would hurt. And then my knee felt like I broke it. I wouldn't have an x-ray one day. It hurt so bad. X-ray was fine. But the next day, so was my knee. Felt great. But then my hips would hurt and I couldn't hardly walk. Next day, my back would hurt. It was really weird. It just every day, some different joints would just be killing me like a cripple or something. It was terrible. And turned out it was the leukemia causing all of that. Weird thing. Nobody could have guessed that. At least none of the doctors I dealt with could have guessed that because it took us a long time to figure that out. The nice thing is this time, we monitor everything. We're on top of it. I'm on top of things early. So I'm hoping we can change the whole course of everything if this is truly coming back rather than have to go through all of that again. Basically, that bone marrow transplant's not 100% because they kill out all my bone marrow, give me the transplant, and new bone marrow grows, and my old tries to grow back at the same time. In theory, when it's successful, the new bone marrow kills out my old bone marrow to where eventually, after a number of years, you don't have any of your old bone marrow left because it's killed out by the new. I have not reached that point, and mine is battling strongly and trying to take over again and kill out all the new stuff. That's bad. So don't know what's going to mean for this class. Don't know how it will affect us, but there may be days you come to log on and Mr. Brock's not here this week or not here this day because I have something going on or some testing or some health problems that I'm not online. So just letting you know, things outside these virtual walls may affect things inside these virtual walls. And I'll try to communicate with you uh, when that happens so that way you'll know what's going on. So in the meantime, we're not going to worry about that until the doctors tell me to worry about that. I was having some of those pains last week though, and my hips hurt for 2 or 3 days, my back hurt for 2 or 3 days. Today is the first day in a week and a half or 2 weeks I haven't had any pain, so that's good. I never had that point before. There's pain every day until all the chemo started, so maybe it's not so bad. But the blood test results showed they looked at 125,000 blood cells, and 111 of them looked like they had leukemia. Okay, that's a very, very minor. That's why they're redoing it to say, is that right? 111 out of 125,000 cells. But the only problem is for the last 3.5 years, it's not found any, no, not detected at all. So 111 is a big deal when it's always been none before that. So we'll get there. We'll see what's going on. But you guys understand math, so 111 out of 125,000 is not a major number. So hopefully this new test can either show that was wrong or that it's not any more than that and not growing. So all right, this week's lesson, 3.05, equation solving. And of course, we're talking about exponential equations because this is our exponential and logarithm unit right here. So let's talk about a few different ways to solve some equations. I'm going to put my screen up here. Oh, by the way, I'll let you know, had a wonderful suggestion from Anne Maria. I have now taken the scenic overlook, that's the chapter summary that's at the beginning of every one. I've taken all the scenic overlooks and I've compiled them into one document and put it in Buzz to where if you want to study for the end of the test, you can go and you can see all of those scenic overlooks all in one document. So I just take them from the front of each lesson, compile them to kind of give you one place for the whole unit summary. So if that helps you, wonderful. You may want to go look through the lessons again too, but you don't have to if you just want to look at those scenic overviews. Good idea, Anne Maria. Okay, so let's talk about considering, our scenic overview talks about when we just look at 2 to the x equals 128. If we were just solving this exponential equation, this one is pretty simple, right? We use the property that says a to the x equals a to the y, if and only if x equals y, right? That's the only time a to the x would equal a to the y, is if and only if the x would equal the y. So this, we know 128, 2 to the x, this is a power of 2. This is 2 to the 7th power. We can rewrite that as a power of 2. So if we rewrite that as a power of 2, it's easy to solve this equation. X equals 7, right? Because we're looking at this, it tells us a to the x equals a to the y. So 2 to the x equals 2 to the 7th. X must equal 7. All right, so that's a simple thing, is if you can rewrite the other side of the exponential equation in the same base, to where you have them the same on both sides, then you just set those exponents equal to each other, right? If we have the same base, we can just set those exponents equal to each other because we know how that rule works. Let's look at the inverse properties that we can use in solving an equation. Inverse properties. Again, this is all in our lesson, so we need to review this. All right, so if we're talking about base A, all right, and we use base A. So our first property says log base A of a to the x power equals x, right? Because the log is saying whatever this base is to this power equals this. So a to the x power equals a to the x power. That's just a simple rewrite. We could also do that, of course, in base E. If I spell base correctly. base e, when we would just say ln e to the x equals x. Because on ln, we don't have to write the base because it's automatically the natural log of e. So this would be e to the x equals e to the x. Kind of redundant, but helps us in solving some problems. Now, if we have an exponent, a to the power of log base a of x, that also equals x. Because a taken to the power of log base a, those cancel each other out, right? Those are inverse operations. Just like here, when we took a to a power and we took the log of a to a power, that's an inverse operation. They all cancel each other out. Or if we were doing e to the power of ln of x, we can do it with any base, e or any other base, whatever base. There's inverse properties that say if we have the exponent of a log or the log of an exponent, they cancel each other out when they're the same base in that. So what happens then when we have, if we have an equation such as this, 2 to the x power equals 3. Well, this property up here is not going to help us in this case. This is not going to help us. But anytime that we have an equation like this where we have this exponent in here, we can, and this is a nice little trick, we can take the log of both sides using any base. We would say, okay, well, give me the log of 2 to the x equals the log of 3. Because if 2 to the x power equals 3, then the log of 2 to the x power equals the log of 3. Okay, we're just taking the log of both sides. All right, so in this case, this is 2 to the x. We can use the property of logs that brings that x out front. So that says x times the log of 2 equals log 3, right? Because that property, those properties we have allow us to do that. If we have this number to the power of x, we can bring the x out front and multiply it. So now when we divide both sides by log 2, x equals log 3 divided by log 2. So x equals, that's when we get our trusty calculator out. All right, let me clear all this other mess I had going on there. Right there. Okay, so log 3, so 3 divided by 2, didn't I? Log 3 divided by log 2. So log 3 divided by log 2 is, I know it's pretty small to see in there, 1.58. Let's round it to 3 decimals. 1.585. So 2 to the 1.585 power, approximately, because this is rounded, will give us 3. And that's how we can use logarithms to solve this exponential that otherwise would be very, very difficult for us to figure out. It would take a lot of guessing or something along that lines. So let's make that a little more. And we could have done this with natural log. We could have said natural log of 3 divided by natural log of 2. It doesn't matter what base we use. This used base 10 because most calculators have base 10. So that we just chose that. We can choose out any of them that we want. So let's make it a little more complicated. Let's say we were solving something just a bit trickier. What if we had 4 to the power of x equals 3 to the power of 2x plus 5. Okay, we're having to solve that for x. We don't have the same base. So x does not equal 2x plus 5. These do not equal each other because the bases are different. If only the bases were the same, boy, we could be all over this. This would be so easy. All right. So let's use the natural log this time. And let's just take the natural log of both sides. So if we take ln, do ln of 4 to the x equals ln of 3 to the 2x plus 5. Again, we can use our properties of logs to bring that x out front. So this is x times the natural log of 4, and this is 2x plus 5 times the natural log of 3. Now, what we have going over here, though, is this is a binomial. So we're going to have to distribute that. And we have to distribute that. So over here, we've got this x ln 4 equals 2x ln 3 plus 5 ln 3. All right, we had to distribute. Okay, so let's move everything with an x on one side, because this has an x, this doesn't. All right, so this becomes x ln 4. When we move over here, we're subtracting 2x ln 3 equals 5 ln 3. Okay, doing that. Then we can factor out an x. Right, so this would be x ln 4 minus 2 ln 3 equals 5 ln 3. Oh, now that we've got that x factored out, we can just divide both sides by that, and we get x equals 5 times ln of 3 divided by ln of 4 minus 2 ln of 3. Now, if they want an actual answer, we just put it in our calculator. All right, so if we turn the calculator on, we use that natural log this time. So we say 5 times, well, I'm going to put this in parentheses just so we're keeping it all straight. Parentheses, 5 times the natural log of 3. All right, close parentheses, because all of that is going to be divided by the natural log of 4 minus 2 times the natural log of 3. I got all the parentheses closed, I think. I think I have extra parentheses, but that's okay. So that equals 9.321. So if x equals approximately, because I rounded to 3 decimals, 9.321, then these two statements are equal to each other. Those are equal to each other. Now, what about when they give us one in logarithm form and they want us to solve it? So let's say we had 4 natural log x equals 5. 4 natural log x equals 5. They want to know, okay, what is x? So we need to isolate the logarithm first. So if we divide both sides by 4, ln of x equals 5/4. Right? So now that we have this statement here, it's the same thing as log of e of x equals 5/4. Right? That's the same thing as e to the 5/4 equals x. So e to the 5/4 power equals x. And that's the answer because e is a number. So this number taken to the 5/4 power is what x equals. Once we isolate that log, we just divided that 4 out from the other side. So let's see what some of the problems look like they're going to give us. Okay, so some of the problems they give us in this unit are you have like log 4 to the x equals 2. Okay, I think you can do that. You know, could it be 4 to the second power equals x? They don't give you the answer. That's straightforward. So you can live with that. What about this one? 10 minus log 8 of x plus 2 equals 9. That's one of those, again, where you got to isolate the log, right? You got to subtract 10. So you got negative log 8. X plus 2 equals negative 1. I divide both sides by negative 1, so then you have a positive that you're dealing with. Log 8 of x plus 2 equals 1. What is 8 to the first power, right? Because log 8, if it equals 1, x plus 2 must equal 8, right? Because log 8 of 8 would equal 1. So now you know what x plus 2 is equal. So, well, my pencil looks really short on the screen there. It's not that short. It's a little work. That is a nice big picture look at solving equations. Whether they give it to you in exponentials, a lot of time we'll rewrite it, take the log of both sides, or rewrite it as a log as we can. And if they give it to you as a log, then you can rewrite it as an exponential a lot of times to solve that. But if you have any trouble with that, let me know. But you guys are pretty good about reading through and solving what you need to solve and all that good stuff. So otherwise, that's all I got to present. Remember, we have this lesson, we have the practice test this week, and we have the Module 3 exam this week. So I've got to get all the Module 4 stuff together and make sure that's in Buzz because it's not there yet. So I got to have that this week. So next week we'll be able to start Module 4, and that'll get us on to Thanksgiving. Like I said, I believe that'll get us all the way to Thanksgiving. If there's any questions, hang around. Otherwise, I'll let you guys go. It's 7:40 this morning. You got time to go have some breakfast for your next class or whatever. And we'll see you next time.
Let's get out of here. Word to your multiples. Math, baby.